Okay, this is the fourth video for Unit 3. We are on page 4. Today we are going to work on orbital diagrams. This is where we represent the ground state electron configuration of an atom. So what would an atom look like with its electrons in its lowest possible energy state? And this is going to be a diagram that shows where the electrons are. An orbital diagram uses a series of boxes and arrows, which I briefly mentioned in the previous video when we talked about the 3 rules of the ground state. Those 3 rules are going to play in here for our orbital diagrams. Each box represents an orbital that 2 electrons can occupy. Only 2 electrons per orbital. Orbital is represented by a box. The electrons are represented by arrows, and those could be pointing up or down. So every arrow that points up would have the same spin, maybe clockwise, and then every arrow pointing down would have the same spin as each other, but an opposite spin from the arrows that point up. So we're going to look at some examples, and this is easier once we've had some examples and some practice. So the first element that we are going to work with is neon. And if you look at your periodic table, it is on the right side towards the top. It is a noble gas. Noble gases are group 18, that very right side column. So we want to know how many electrons it has so that we can write down where these electrons should be. Step 1 is knowing how many electrons. So neon, first off, let's talk about protons, then we'll talk about electrons. Remember, in this unit, we are only talking about neutral charge atoms. Neutral charge means that we have equal numbers of protons and electrons. This is the 4th video for Unit 3, and we are on page 4. Today's topic is orbital diagrams. In the previous video, we talked about the ground state electron configuration of an atom. Basically, where are the electrons when the atom has its lowest possible energy? An orbital diagram is a representation of that, just a very basic drawing that shows us how many electrons and where they are at. An orbital diagram uses a series of boxes and arrows to represent the electron configuration of the atom. Each box represents an orbital that 2 electrons can occupy. Electrons are represented by arrows, which either point up or down. Every arrow pointing up represents electrons with the same spin. Every arrow pointing down would have the same spin as each other, but an opposite spin of the arrows pointing up. So as we're talking about orbital diagrams, we may need to refer back to the 3 rules on the previous page and in the previous video. The easiest way to figure out orbital diagrams is to see a few examples and then give them a try yourself. So we are going to do some examples. Example 1 is neon. First, look at your periodic table. Neon is on the right side towards the top. It's in group 18, which are the noble gases. So in this unit, we are considering every atom to be a neutral atom, just to keep things simple. Neutral atoms, that means that the atom has an equal number of protons and electrons. Protons have a positive charge, electrons have a negative charge. When they are in equal numbers, the number of positives and the number of negatives cancel out, and that's how we get this neutral atom. So before we can draw an orbital diagram, we have to know how many electrons does neon have. If we look at the periodic table, we can find its protons, and from there we can figure out its number of electrons. So neon has an atomic number of 10. That means 10 protons. Since this is a neutral atom, everything in this unit is a neutral atom, we have an equal number of protons and electrons, which means in this situation we have 10 electrons. Now we have to think about the sublevels that we talked about in a previous video and the 3 rules that we talked about in the last video. So energy levels come first. Energy levels are numbered 1, 2, 3, 4, 5, 6, and 7. Let's write this down. Energy levels. They're 1 through 7, and they work consecutively. 1, 2, 3, 4, 5, 6, 7. Then we have sublevels, and that was S, P, D, and F. And then we have orbitals. And so remember, for each of these, we had 1, 3, D has 5, F has 7. Here's how it works. So energy level 1. Remember, the S sublevel fills first in every energy level. So energy level 1, sublevel S, 1 box. S has 1 orbital. So we can go ahead and put 2 electrons in here. There's 1. There's a second with the opposite spin. But we've used 2 and we still have 8 to go. This is it for the first energy level. So we end up going to the second energy level. And remember, the S fills first in every energy level. 1 box, 1 orbital, it can hold 2 electrons. So if we look back at our section on the sublevels, we see that the P fills immediately after the S, and it first appears in the second sublevel. So the next one is 2P, and it has 3 orbitals, which can hold a total of 6 electrons. 3 orbitals, 3 boxes. And here's how the electrons fill up. Remember the school bus idea, Hund's rule. So you get on the bus, you take an empty seat. Next person gets on a bus, they take an empty seat. Nobody doubles up until all the seats have one person in them. So in this 2p sublevel, we have, here's an electron in this orbital. Next one goes into this orbital. Next one goes into this orbital. So we have 7 electrons so far. We need to have 3 more. And so now they're going to double up. And now we have 10 arrows representing 10 electrons. And this is the orbital diagram for neon. This task might seem a little bit daunting at first, but keep in mind that these orbitals and sublevels fill up in the exact same order for every ground state element. So once you know the basic order, then it's just a matter of drawing your picture. Example 2 is going to be oxygen. So let's go to our periodic table. Let's figure out how many protons, how many electrons. So on my periodic table, it is towards the top right. It's in group 16. The atomic number is 8, which means 8 protons. We're treating it as a neutral atom here, which means it has an equal number of electrons, which is 8. So we're going to have 8 arrows that we're going to fill into our system of boxes. I'm going to do it directly beneath this one, and really we can use this one as a pattern as we're learning these. So remember, energy level 1 comes first, sublevel S comes first. First energy level, sublevel S, holds 2 electrons. And there they are. And that's the only electrons that can fit in this energy level and this sublevel. Next comes our 2s. Again, one box, meaning only 2 electrons can fit. There's 1, there's 2. Next up in the second energy level comes the P sublevel. The P sublevel has 3 orbitals represented by 3 boxes. So far we have used 4 electrons, and so we have 4 more to put in here. So here's 1, here's 2, here's 3. Now all the seats on the bus are full. We have 1 left, and it's going to have to double up. So right here, opposite spin, and it's going to fill the first box, arrow pointing down. For example 3, we're looking at magnesium. It's towards the left side of the periodic table. It's in group 2. It has 12 protons, and when it's neutral, it has 12 electrons. It's going to follow the same pattern as the rest of them. So the 1s comes first. There's 1, there's 2 electrons. You can even keep track underneath if you want. This part's not necessary. Second energy level, the S fills first. Here's 1 and here's 1. Now we've used 4. 2p has 3 orbitals represented by 3 boxes. So we're at 4, here's 5, 6, 7, doubling up, 8, 9, 10. take a look at that, we are at the same point where we were with neon that had 10 electrons. But we have 2 more to go, and we've hit the end of the second energy level. The next energy level is 3, and remember the S always fills first. $11, $12. That is it for magnesium. Last example for now is silicone. Looking at your periodic table, it's in the middle but towards the right side. It's in group 14. Silicone has 14 protons, and if it's neutral, it has 14 electrons. So we start filling this up in the same way. The 1s comes first, then the 2s, then the 2p. Remember, 2p gets us to 10, and we're going to 14, so we're going to fill this all the way up. 3s comes next. That gets us up to 12. After the S comes the P. It is 3 orbitals represented by 3 boxes. We only have 2 more electrons, so we'll put 1 here and 1 in the next one. And if this were a bus, we would have a lot of empty seats. In the same page where I talked about the sublevels, I mentioned that groups 1 and 2 corresponded to the S sublevel. So magnesium was in group 2, and look at this, it ends with an S sublevel. I said that the P sublevel corresponded to groups 13 through 18. Here we have neon as group 18, and it ends with the P sublevel. We have oxygen in group 16. It ended in the P sublevel. We have silicone. It is group 14. It ended in the P sublevel. And so that's what I was talking about with the arrangement. You can get this idea of maybe how did they put this stuff together. Groups 1 and 2 are the S, 13 through 18 are P, transition metals are D, intertransition metals are F.